All right, we're live. So, well, we're just hanging out for a few minutes. We were just talking about the JetRacer and what we've got going on. If you see it, you can see it behind me now. And actually, I'll share real quick. Just a second. I'm going to. There we go. Not sure what that was about. Good old Thursday morning sneeze. I hope I don't have COVID again. Just kidding. I don't have COVID again. So let me show you. This, what you're seeing right here, is directly from JetRacer. And I have to grab my other keyboard and mouse to like do stuff on it. So I wonder how bad the latency is if I can just like use it. Wow, that's not half bad. A little bit of latency, but I can just like I'm looking at my StreamYard stream, and I'm actually just doing stuff over that. Let's take a look.
Actually, if you notice, it's pretty funny to watch you because you can also see it being done to the computer behind you, and it's like a 1-to-1.
That's a little creepy, huh? Yeah, but let's see how typing is. Oh, the enter key. I'm on the wrong keyboard. And okay, so I have to like grab my other keyboard too. But we can do that. Let's just try it real quick. We're hanging out while people show up. So I've got here my. Let's just trying to break anything while I do this. What am I tangled? I'm tangled up here. Just a bit tangled. Here we go. So now I've got the right keyboard.
Sounds like we need to get you a bigger desk.
Yeah, Paul.
Get you one of those L-shaped desks so you can put the computer on the other side with the JetRacer.
Yeah, it's working. So it's actually not half bad. A little bit of latency, so I just have to move slow. But, oh man, let's fix that typo. Cool. So, this is how we're going to, dang it. There's my first latency misclick. There we go.
So do you know what operating system this is running? Is it just Linux or is it a specific flavor?
Is that how you say it?
Ubuntu?
What's that?
I say Ubuntu, but
Ubuntu.
But everybody says it differently.
Sorry, so. Linux people in the world. I am I'm not I'm brand new to Linux. So funny story, when I was a kid, when I was 11, we got our first IBM compatible. That's what they called PCs back then. IBM compatible. And it came with, it was like a 386 something with, nothing by today's standards. I mean, I'm sure that, the Jetson's way more powerful than that computer was. But it came with Windows 3.1. And if you're not familiar, that is the first version, like the first production release of Windows. And my dad had never heard of it, didn't know what this fandangled graph GUI stuff was. And so he uninstalled Windows from the computer, and we used command line for everything. Just use DOS.
Oh my god! I was about to say, I was like, at least you didn't have to use DOS, but
we did.
I guess he reverted back.
So which I didn't do anything. I mean, all I did was change directories, and like we had this game Captain Comet. I'd go over there and launch Captain Comet and play Captain Comet, or there was like a Paint kind of an application. We'd make posters and print them on our dot matrix printer.
Oh gosh.
And it was really fun. Hey, you know what though? The cool thing about dot matrix printers is all those papers were attached by a perforation, so you could make really long, cool banners. You can't do that now, so not like you could then. I can make
You
as
can-
long of a banner as I wanted on our just regular old home computer.
I mean, you can. You just go to the airport and you could ask them to print out something
Yeah,
because they
well,
still
I'm
use
home. I'm
those.
home. Yeah, so forget your 3D printer. We had a infinite length banner printer. So now we're talking
Oh,
low tech for the win. All right, I'm
oh
going
my
to pull off the Jetson though. We don't need that yet. I'm on the wrong mouse and keyboard. I'm like, why isn't this working? Let's put these away. Let's see if I can untangle better as I do it.
And I guess for those who are joining in, this is all being streamed off of the JetRacer.
Yeah, direct stream from the JetRacer itself,
Yeah.
which is kind of cool.
Which you can also see in Eric's background. It's on that monitor right there. That is what
And
is being streamed here.
this is the display, and this is the computer, which also happens to be a robot, which is so cool. I was watching this cartoon with my son yesterday, Captain Underpants, and he talked about how robots are always in the future, and I'm like, no, robots are now. Great question here. We've got some questions rolling in. Lots of highs and greetings. And can I ask a question about Isaac Sim
I think that's supposed to be
cars with ROS 2 bridges? You can ask, but unfortunately, I do not know anything about ROS 2. I think Papa Chuck might, and some others in the community might. So I hope you'll join our Discord channel. Let me share a link. Let me just get that link here. Jen might beat to it.
Oh, do you want me to?
No, that's okay. I got it. So here's our Discord link. Join us and join the JetRacer channel, and we'll chat with us there. Happy to chat about that stuff. We've decided not to use ROS 2 for this project, for this first project, and because we're just going for the simplest, lowest barrier to entry tech stack that we could think of. Because we want, so if you're interested in robotics and AI, we're trying to help you start a business. So we're trying to come up with what is just like the minimum viable product that you could go out and use to make some money. And we think this is it. Instead of ROS 2, we're just using a Jupyter notebook. It's so simple. And we're coming up with one architecture that can run on your PC with Isaac Sim. And then you deploy that exact same set of classes to your Jetson device and run that Jupyter notebook on the Jetson, and you have a working robot that runs off of AI. So let me share my, this is my local computer. Let's open up, did I forget to, I hope I'm on VPN. Just a second. I might need to be connected to VPN. Nope, I'm on VPN. Great. So let's hop over to JetRacer. And here we go. Here's the JetRacer. And let me just show you first what we've got going on. If I go to extensions, we're going to launch the Jupyter Notebook here. Did I catch it in time? I hope so. Window. I did. So we're going to follow the instructions here and go to 127.0.0.1:8225/lab. And we got this part running last week to the point where we had this up. And let me just show you. I'm just going to make this small. Oh dear, I lost it. Okay, we've got a kernel selected. Let's start our simulation. And Boom. You see that steering go? Watch it go again. There it goes. So we're controlling this robot from this Jupyter notebook. It is totally working. I'm driving the joints with it. Okay. So yeah, I'm going to show you how I did that. And then I'm going to show you, well, and just so you know, this Jupyter notebook came from Chitoku Yato, and it's just his notebook for controlling this JetRacer with a Jetson Nano. So if you have a Jetson Nano 4 gigabyte or 8 gigabyte, he's got a pre-prepared image ready to go. You can install and add to that Nano, and it will already run this Jupyter notebook. Now I have an Orin Nano I bought. I'm trying to be all fancy, so I bought a different Jetson than he used, and so we've got to figure out some stuff. We've got to configure it. So it's not working yet. Maybe I've plugged something in wrong, but I think it has to do with the pin addresses and the bus addresses, and that with the Orin versus the original Jetson Nano. So, but first, let me just show you what I've done here. Let's just take a look at this notebook. You can see from .NVIDIA race car, import NVIDIA race car. Now this dot makes it a relative path. And what I've learned, the working directory in Jupyter is kind of goofy. It's like often, where is it even? It's not even here. You've got to go up a level from this. And then there's a folder with your modules, and that's like this working directory. But what I learned is if you don't do the dot, then it just looks in your local directory in the same directory as your Jupyter notebook. So I've actually I just copied the files over to my Jetson and made those changes there. We'll make those changes here at some point. Heck, maybe we should do that now, huh? Just to get that working. Well, let me show you how I've done it. Actually, I've got to open that code. So yeah, let's do this first, okay? We want to do video. Got this really cool tool called Everything. It lets me do searches on my computer really quick. I love this thing. Here we go. Open path. Okay, so here we've got the classes. NVIDIA race car and race car. Extension.py. What are you about here? Did I open it? I don't know. Open it in something else. Oh, I was trying to run it. Open with VS Code. Let's take a peek at this one.
Can I just say I enjoy that the imports look like it's a pyramid at the top of that file?
Oh, let me just open it. Kind of satisfying.
Yeah. Do that.
It's sorted by length. I like it.
Yeah.
That's the way to do it, huh? Okay. But we're going to take these two files. I'm going to cut them and go to here, data, notebooks, JetRacer. No, notebooks right here. And put them right next to the notebooks. Now, because what we'll be able to do is we'll be able to publish this to GitHub now. So then we can have a GitHub repo with just this one directory. We can have it here. We can pull it from the Jetson. That'll be an easy way to deploy. Versus, I was doing FTP, like secure FTP through the Linux command line, and that was just a little bit irritating. I don't know. As I get more used to Linux, I'm sure it'll be fine. I think that's kind of the way they work.
Oh, I feel like one day you're going to be so in love with it that it's not even going to be funny anymore. And you're going to be like, what's Windows? Windows is, nah.
Yeah, right? Maybe someday. Okay, now it's mad at me because I There we go. I've got my folders now. Here's an interesting question. Can you please tell me if it is possible to connect it with mission control? I don't know what mission control is. What is mission control? Is that a robot, kind of like Ross 2? Let's see. Robot mission control. Oh, cool. Let's take a look. This is a cool thing. This is a cool rabbit hole. I'm wondering if this is it. So let me know. Annie Root. I'm gonna do my best with your name. Annie Ruda is asking about it, and it looks like it's kind of like a what do you call it? Like telematics? No, that's not it. It's keeps track of your robot, tracks your robots for you.
It's like a hub,
Yeah,
like a central hub for all of your machines.
that's cool. I'm going to say almost certainly, and the reason is because to connect anything with to connect things to Omniverse, if they can work with Python, you're good to go. And so mission control, it just from the first glance, it looks like it's using web requests, probably has a web API. It could even have a Python library already. A lot of these things do, especially in robotics, right? Robotics is very Pythonic, I'm finding. And so I would say definite maybe. Let's see. Technology. Yeah, anyway. Worth looking into, but I would say probably. Let's okay, now if we run this, it's gonna hate us because we moved that file, so it's gonna fail. Okay.
No.
No module. But we should, I'm hoping, just have to do that. What? Dang it. So, any thoughts there, Jen? How can we organize this so it can find? Because when I run this on the Jetson, they just have to be next to each other in that same folder. And as long as I remove the relative path, it works just fine.
So wait, so we had it working in Omniverse, right?
Yeah, but the folder structures are different for the two Jupyter Notebook deployments. You see what I'm saying?
So are we still trying to have it work in Omniverse, or are we trying to have it work
I want one folder structure that works in both places.
in both places?
Yeah. And ideally, I thought I could do a relative path. And I wonder if there's like a Jupyter Notebook setting or something that would let me change the home directory, you know?
That was a great question. I feel like there is an answer for that. It's just hard for me to remember because we're using a spinned up web server for it, so on the local machine. So the UI is a bit different.
Yeah, I think for now, let's just change it back. And that's a good thing for me to work on during the week. It's not very exciting to watch me like try to figure out relative paths. So I'm just going to change it back. And you just but check it out. I copied and pasted instead of cutting and pasting. Or did I? No, I didn't. No, they're still here. So grab race car and NVIDIA race car. Let's cut them out of here. We're going to go to here. I don't know what SEMU means, but that's where he goes. Scripts. No, that's wrong. I went in the wrong place somewhere. No, I didn't. Yeah, right here. All right. Put him back. Just, yeah, that's something that's got to be sorted out, right? Is getting the getting that sorted. So making that structure the same. All right, so this ran, and if you recall, let's just double check that it's still working. Yep, it just turned those wheels, and it just turned them back. Great. Let's look at the code. And to do that, let's just look at both. These are just the two classes. So if you look, we're importing NVIDIA race car. Let's take a look at that. And if you notice that NVIDIA race car inherits from race car, so let's take a step back and look at that first. See what that does. I like to start with the base class, you know. All right, cool. It's really simple. We've got a steering property and we have a throttle property. That's it. And then we have this traitlets import that is pretty cool. I didn't know about this one, but it basically creates properties for you and lets you subscribe and validate your properties. So in this case, we have this markup that says we're going to validate the steering property. And all this does is if you pass a value that's outside of, it just clamps the value between -1 and 1, which is all, if you look at the, my remote control here for our RC car, these just signal full throttle is 1, full reverse is -1, full steer right is either 1 or -1, and full left is -1 or 1. Okay, it's easy peasy. So all this is doing is keeping your steering and your throttle properties within bounds. So now let's look at the race car. Now I've added some stuff here. I'm going to comment a bit. Okay, so those are my Omniverse imports.
Is IRL supposed to be in real life?
Yeah. You like that?
Yeah.
And then you've got, so if we're working in Omniverse, we're just going to import our Omniverse stuff, right? If we're working if we're in real life, we're going to be using ServoKit from Adafruit because we're using an Adafruit servo driver, which is a simple yet perfectly respectable servo driver. Okay, nothing wrong with that. So there we go. And all I'm doing is and if you look in my newer code, like this is only working on this is the code I had working on Omniverse. I've been tweaking it. Let me show you on JetRacer, actually. So if you look here, I've changed it a bit. So first I try to get the Adafruit import. If it's not available, then I grab the Omniverse stuff. Actually, I'm just going to show you this code because this is actually even better. Because it's actually a little bit further along, although it should still work on both. There you go. Okay, so now there are these addresses. There's this I2C address. And what I've learned is there's this thing called so this is an I2C bus is just a set of communication pins. And the Jetson, both the Orin and the original Nano come with 2 I2C buses in this set of pins. And so essentially you can plug stuff into these pins and communicate with them through these buses. And the buses have an address. Now the address is actually, so either is bus 0 or bus 1, or in the case of in the case of, that's the one problem. The original Nano uses buses 0 and 1. The Orin Nano uses buses 1 and 2, or vice versa. One of those. They don't have the same pin numbers for the buses. Okay, so here we've got these bus pins. Then right here, I've got the Adafruit servo controller, and it's what is it called? It's a PCA 9685 servo controller, which is a standard style of servo controller. It was got 16 controls 16 servos, which can be daisy chained, so it can control 16 times 16 servos, which is pretty impressive, I think, for this little teeny chip. But basically, this by default expects to be addressed at this specific address, which is hexadecimal 40. But you can solder on these little pads to change the address of this thing. And that way you could have a couple of these boards. Yeah, so really you could control 2 of these boards. So you could control 32 times 16 servos with one Jetson. And that's with a Nano 8 gigabyte or with the Orin. So I don't know. I don't see myself needing that many. It's a lot. What's 16 times 16, people? 356, 365?
Yeah, 356.
356 times 2. So 712. You could control 712 servos with this thing.
Ooh.
It's a lot, right? I feel like it's a lot. It feels like a lot to me. We're doing 2. Actually, we're doing 1. We're trying to get the steering to work. All right. But honestly, I think once you had the addressing down, it would be fine. So let's see here. That's the address of this servo control board, which by default is hex 40, 0x40. I don't know how you say that out loud. 40. 0x just means hexadecimal. 40 means 40. Or, well, it means 40, which is not the same. It's not 40, actually. It's a lot bigger number. All right, the steering gain. So this just means, if you put a number of 0.3 or something, or 0.5, this is going to flip it and make it, 35% smaller. So you don't go too big with your steering. The offset is like your trim. So it changes that 0 point. And then the steering channel is that set to 0, and the throttle is set to 1. And that just means that if you look at this board, at this servo board, so the default address is 40. Well, this is 40. That's 41, 42, 43, 44, 45, 46, 47, 48, 49, 4A, 4B, 4C, 4D, 4E, 4F, all in hexadecimal. So those are the addresses of each of these servo channels. So, and so basically this is saying steering is going to be 0 and throttle is going to be 1, which by the way matches our receiver. The channel 0 is the steering and channel 1 is the throttle. So off of this guy. So it kind of, it makes sense. And then there's also a throttle gain, which just kind of tones down the throttle a bit. Yeah. Oh, this is kind of a cool comment from Papa Chuck. These pins are really cool. You can put an oscilloscope and see it in action. Even make your own IC to talk to Jetson. Yeah. You can even, this is the Jetson developer kit. So it's got the Jetson board. So this is the Jetson right here sitting on it. And then all this other stuff with the USB ports and all that, that's the developer board that you can do that, or you could do your own custom board, or there are commercial Jetson boards. So yeah, kind of cool. Let's see. I did, and just a little random note, I did learn that the Orin has 2 NVMe memory slots, so you can put some really high speed memory in there if you want for your hard drive.
That's
And
nuts.
I got to learn how to write to it. And I bought a dang SD card, and I learned that the NVMe memory is cheaper than SD cards.
Yes.
Even though it's way faster. So I'm
Yeah.
kind of like, but that said, it's to write the NVMe, to flash your OS to the NVMe memory is non-trivial. I'd say it's a lot easier to write because you got to put the whole OS image onto this thing. And it's pretty easy with the SD card. I was reading about how to do it with the NVMe stuff, and it was not as easy. All right.
Well, I'm gonna hop off for now. Hopefully, Edmar can take my place. But
he should be here any minute.
I'm gonna watch the rest of this stream later because this is very interesting.
Things are getting kind of cool, right?
It's pretty cool. So if you're not here, don't be square. Be here.
Yeah,
this is cool.
And we're just like one step away from getting this same Jupyter notebook to make those wheels move, which is so cool.
That's nuts.
I think I had to solder on my servo board, which to put it, it just scares the crap out of me. This is so out of my comfort zone to like solder on a computer chip that I bought,
Yep, I agree.
Oh gosh,
I agree. But I'll see you on the other side.
Yeah, we'll see you later. And Edmar should be here any minute. We're going to talk about SIGGRAPH, which is coming right. Oh, speak of the devil.
Aha!
Edmar,
yay!
Am I the devil?
Yeah, well, we're trading places, so I'm leaving and you're coming, so it works out like that.
Perfect.
And we got to show Edmar this cool. I just got to show him the little show and tell real quick.
I'm excited to see what you guys have done since last week.
Okay, so let's restart this simulation.
Oh boy.
And here's my Jupyter notebook. So this is the Jupyter notebook.
Awesome.
And watch these front wheels on this RC car. Boom.
Nice.
And then here they're going to go back. Boom.
Very cool.
And this Jupyter notebook, with some tweaks, we're not quite there yet, but it runs this Isaacson one. This Jupyter notebook actually runs a car built off of an original Jetson Nano, and I'm modifying it so it'll run off of my Orin Nano.
That is awesome.
So one Jupyter notebook will run either sim or real life. So
very
you just
cool.
deploy it either location, and it should work.
That is awesome. Wow, you guys have gotten a lot done.
Yeah.
Ooh.
Yeah, I really am. I'm like a kid in the candy store over here with my robots and my codes and my notebooks.
So good to see you, Papa Chuck.
Yeah.
Papa Chuck had a great idea actually for a new live stream kind of series, I guess it would be, and that's on the infrastructure part of Omniverse. So Papa Chuck, that was a great idea. You posted on our community Discord server. I'm talking with the dev team now to see if we can line something up. So get your questions ready. I'll let you know when we schedule it. But very cool to be here. And so Jen, you got to go.
Well, I actually thought I did, and then they just moved the meeting. So I was like, oh.
Jen will stay with us.
So I guess I'm staying. It was like a last minute thing. Like I was like, what? Okay, I guess it moved.
It's actually perfect that you guys you're both here together, because what I wanted to mention to the awesome audience is that SIGGRAPH is just around the corner. Jen and Eric will both be there. Actually, all three of us will be there.
Yeah.
I'm going to post a link in a few minutes to a calendar where anyone who's going to be in the LA area, whether you're at SIGGRAPH or not, if you're just in that area and you want to meet up with us, the community team has this great calendar. Let me know if you could feel free to ping me if you'd like to set up a meeting with Jen and Eric. These guys are you guys are hosting workshops, right?
Mm-hmm.
Yeah,
that is right. There's 2 workshops we're doing. There's one where it's fundamentals of USD, and the other one is creating your own 3D scene manipulator in Omniverse.
That's awesome. So anyone who's going to SIGGRAPH, you definitely don't want to miss the opportunity to hang out at these workshops, meet the development team, And we also have a cool USD playlist that Aaron Look has been working on. We've got, I'll put the link in a couple minutes. So to further your kind of prep for USD, you have some great video tutorials that have just come out recently. Anyway, the big thing about SIGGRAPH is not only we'll be there, but this guy will be doing a keynote there, Mr. Jensen himself.
Not me. Not me.
But pointing this way. Sorry, this guy right here, like with the cool leather jacket. So yes, he'll be presenting at SIGGRAPH, and that is available to anyone to watch. So I'll post a link for NVIDIA's SIGGRAPH page, and you can put in a little calendar reminder. We also have it up on our Discord server. But yeah, so you don't have to be in LA or attending SIGGRAPH to be able to watch the keynote. It's going to be pretty mind blowing. We have a lot of people on the team working on this right now. I just mentioned this great USD series. If you want to if you're going to SIGGRAPH and you plan to go in those workshops, this would be a great thing to watch before you go to ramp up and come prepared with those even deeper dive questions to Eric and Jen and Ashley and Paul. Paul will be there also. My colleague Maddie will be there. It's going to be a lot of fun. So anyway, you can ramp up on USD from Aaron Luck's series here. I'll post a link in the chat in a minute. We also have just recently announced, and we kind of did this live stream yesterday, our community challenge called Start to Finish. So we would love to see where something started and where it ended up in the Omniverse kind of foundation of any kind of apps you're using with OpenUSD, especially. Be really cool. So we had several creators come on yesterday: Tanya Langner, Gavin, and Andy, who did an MC Escher Omniverse scene animation. Really, really cool. Shang-Chi came on yesterday. Really, really cool. And of course, Jay Dizzle, who came on, who's an employee of Nike, who deals with materials and rendering at Nike. Actually, he was on our live stream yesterday also. So if you want to watch that, it's on our YouTube channel. You can catch it now. But we also, this community challenge is going through August. So we would love to see your work. Post it on social media with Start to Finish hashtag and tag at NVIDIA Omniverse and at NVIDIA Studio. We will boost and celebrate your great work. And then finally, we've got a great connector. We had this live stream also pretty recently with the Marvelous Designer team. If you're working with fabrics and characters, you should totally check out the Marvelous Designer Omniverse connector, which lets you really have streamlined workflow for working with fabrics, and could be costumes, it could be curtains, it could be couches, whatever you're working on to bring your scene to life with fabrics. Marvelous Designer is a great tool to work with, and is part of the Omniverse Foundation with this connector. So those are the main things I wanted to share. And I'm going to post a bunch of links I just mentioned in the chat, so I'll stream them through in a few seconds. But you're really excited and so cool that you guys will both be at SIGGRAPH with us. It's going to be a lot of fun.
Cool.
Yeah, it seems like Papa Chuck says that you need to bring me coffee.
I will bring. Do you want Vermont coffee? I could bring. We have a great Vermont roaster here.
Oh, now it's got real.
So you would prefer the ground? I'm sorry, the beans, right? The whole beans.
The whole beans, yes.
Keep it super fresh. All right. I'll bring some extra if anyone else in the community is coming. I'll dole out some Vermont coffee.
Now I'm expecting there to be whole bean coffee. So if you don't bring me some,
I will.
If you don't, I'm going to be really sad.
It will be there. Very cool. So yes, I can hang out for a few minutes if you guys want to continue on with the.
Yeah. So let's go back to. I got to get the right mouse first. Let's go back to local and let's show how the Omniverse side of this works. Alrighty. Yeah, so we're just doing some imports. We can either import the. Oh no, I was going to do it on the JetRacer. So that's my latest. Just a second. Changing mice. Here we go. Yeah, so we're importing either. We detect if servo kit's there, and this is not the most robust way to do it. It might be better to just set a flag or something at the start of the run if you're in real life or on Omniverse. But then we set our addresses to the pins so we can write to the servo in real life. And this could be commented out or put into an if statement. So it only runs if we're in real life. But I actually kind of think it, I don't know, I'm thinking about that. It might be cool to, instead of doing it this way, to have a separate class that's like our own Isaac servo kit kind of a class that lets us kind of emulate the servo kit from Omniverse. But for now, we're just doing this. So we've got the constructor here. If we're in real life, I'm doing these prints trying to figure out what's going on. I'm trying to change the address of the board to speak to so it can work. But if we're in real life, essentially we're going to create, here's our I2C bus we're going to set up, and we're going to set the addresses, kind of create a steering motor and the throttle motor that we can control. And then you'll see down below, we have this response to if anyone changes the throttle. If it's real life, we're going to set the throttle on the actual robot. Same kind of a thing here. Let me just hide this. If it's real life and someone's changed the steering value, we're going to write to the motor. And then here we have, if we're in Omniverse, I'm just grabbing the stage and grabbing the drive, or grabbing the servo arm right here. That prim that has that drive joint on it. Sorry, that is the joint. That's the joint I want to drive. And then I've only done it for steering so far, but if someone changes the steering value, I'm just going to grab that drive and change its value. And I just put a little, at 0. It's in degrees. So the real servo is a signal from -1 to 1, and 1 would be the maximum rotation of that servo. Whereas in Omniverse is in degrees. So if we try to go to 0.3 degrees, it's like nothing, right? You wouldn't even be able to see it. And so I'm just pumping that up so that it's going to 30 degrees, which is about my max. I mean, we're just hello worlding here. It doesn't have to be exact. And that's it, guys. That's it. We've got this class right here. This simple little class is letting that same Jupyter notebook. Let's pop over to it. It's breaking right now, but we're just making the race car, changing the steering, changing the throttle, and it works. It works in real life, and it works on Isaac. And we deploy the same package, either location, and it'll run. I'm having some trouble with my addresses, but I think this is going to work great. I'm really feeling good about it right now. And I'm just curious what your questions are, because I've gone through this maybe a little fast. I know that, this represents a week of me learning about robotics and talking to the robot guys and talking to the Isaac guys. And I'm new to this area myself. So it's been, just learning a lot about this stuff. And I think, like from Papa Chuck, he's been concerned, well, how are we going to talk to the, PCI Express bus on the computer, or how do we emulate? And I was worried about how do we emulate it, and how do we make an emulator that really works well? And I think that this has really turned out to be pretty simple this way.
What would you say? So the Isaac team actually was just planning earlier this week their next series of live streams and webinars. So I'm curious, Eric, how you found the overall documentation and the kind of the ramp up process with learning Isaac Sim. Did you watch videos? Did you leverage documentation more?
Yeah, the only real thing I've done in Isaac Sims, I took a Deep Learning Institute class on Isaac Sim. There's like a welcome or build your first robot class on DLI. It's free, so you should all take it. You don't even need it's just all over the web browser. So let me see if I can find a link to that class. That's a great start.
I found it. I'll put it in the chat.
Cool. Yeah, that was really helpful for understanding Isaac, just at a very, very low, like shallow level. But really, most of what I've done is to set up these joints. And for that, just goofing around with it quite a bit. That wasn't this week. I did, I've done that in the past, worked on it before. But also there's some good physics samples. Like there's this physics buggy in the physics samples. Let me see if I can.
Yeah, everybody has access to that in the mount, right?
Yeah, absolutely. Let me share my screen here. Go to Window, Simulation, Demo Scenes. And then if I go to, is it Rigid Bodies? No, it's Complex Showcases, I think. Here we go. Lego Technic Buggy. This buggy, it's got joints, it's got articulations, it's got the steering, so you can control it with the gamepad. It's got lots of good stuff in that one that helped me a lot. And then and then just debugging with some Isaac people to get my contacts set up, and I've done that in previous live streams, and so people can refer to those. Making these contacts spheres instead of jaggedy SDF meshes really helped. Making sure that just being meticulous, making sure that all my joints were set up correctly. All right. But yeah, as far as Isaac goes, that was it. And then as far as, I had this assumption going in that could be wrong, but I worked at a previous job where I was working with a Bluetooth enabled device. It was like a lockbox, and then you would log into it, you would connect to it with your phone over Bluetooth, and then you could like unlock it, or they had like RFID cards you could use to unlock it too, and so you could configure those and set up guest access and do all this stuff. And what we very quickly learned is that firmware is by the hardest development part of that whole ecosystem. And so basically, whatever's easiest to do with the firmware is easiest to do overall, because firmware is so hard. And so it makes it really easy. You just go to the firmware guy and say, how do you want to do this? And he's like, this is the easiest way. And he'll be like, okay, that's how we're doing it. And then the whole rest of the architecture, it doesn't matter how hard it makes it, it's still going to be the easiest way to do it, because firmware is so dang hard. I mean, it's in C, for Pete's sake, right? Not C++, C. And yeah, it is gnarly. So, and we're doing encrypted communication. So like, however it's easiest to encrypt communication on the firmware side is going to be I can do whatever I want from the phone. I've got a lot of flexibility. And that really worked well in that situation. And in this situation, I kind of made this assumption that working on the robot itself is going to be harder and more constrained than Omniverse is, because Omniverse is so open and so easy. And so I just reached out to Chitoku Yato and said, how did you do it? You've got the JetRacer, you've got it working. How did you do that? And he says, we used the Jupyter Notebook. So then I said, we're using a Jupyter Notebook. And sure enough, it really hasn't been very hard to adapt that Jupyter Notebook to work in the Omniverse environment. So I feel like that it worked out this time. And I would say that's going to be a good guiding truth principle or whatever, is that however you need to deploy to your actual robots, if that's a containerized, replicated environment, you're going to be more constrained on the Jetson than you are going to be in Omniverse. So just do what works on the Jetson, figure that out first, and then just figure out how to integrate it with Omniverse after that,
Great advice, great wisdom.
There you go. But yeah, man, I just wish. I think next week next week I'm out of town, and the week after that we're at SIGGRAPH, and a week after that we'll be back.
Mm-hmm.
But I post this stuff to the Discord channel all the time. So if you join us on Discord JetRacer, I should be able to post a real life video of this real car steering. Wait,
You have one more week for SIGGRAPH. SIGGRAPH is in. You have
SIGGRAPH. No, I'm here next week.
Yeah,
I am here. No, so next week I'll be able to show it.
Okay.
Yeah.
SIGGRAPH is August 6th through 10th, so you have a couple weeks.
Yeah, so I've got a couple weeks. Yeah, so we'll show it off. We should be able to show that off next week.
You just won't be here August 3rd. That's
right. We won't be here August 3rd. And just wish me luck, because I think I might have to solder on this servo control.
Ooh.
Yeah,
Film it.
I'm a little nervous.
Fingers crossed. I understand the feeling. It's not fun. It's painful, and if you over solder or it's not fun.
Do you do that a lot, Jen?
Oh, because I still play a lot of my Game Boy games. So in order, like at some point the battery dies, and the battery is actually soldered onto the board for the Game Boy games. So I always freak out if I'm gonna, ruin the game and the stuff, because I have to solder the battery onto the board. That's
hardcore.
Yeah, right. I wonder if you could just solder a plug on next time.
That's what I was thinking, but the fact that it has to fit within the cartridge.
Tight packaging, huh?
Yeah, it's stupid.
Yeah. Yeah, so that's where we're at. Yeah, I just let me see if I've gotten some. Let me check my Slack. Some people might have reached out to me with some help. I've been pinging people like crazy. No, not yet. I'm a little bit ahead of some of them hours wise.
Ooh, let me check on that course. Let me check.
Oh, I think there are 2 courses. Let me double check here. NVIDIA DLI.
I know one of the USD courses is $30.
Yeah, the one actually. So thank you, Birdaid. That is correct. The link I posted is $30. So Eric's looking right now for the free one.
Oh, I hope there's a free one. All courses.
You know what? Well, let me check actually with the team and see, does it have to be $30?
If it's using a VM, yes.
Is it using a VM though? Let me see.
Oh, shoot.
Yeah, it's hard to tell. It's a little ambiguous.
$30. Yeah, shoot. I think it might be.
Which one is it? Is it the
Introduction to Robotic Simulations in Isaac Sim?
Yeah, it is $30. I'm sorry.
But let me ask about this one.
It does use the VM.
It does. Okay. Oh yeah, Omniverse streaming client app. I see.
Yeah. If it's using the Omniverse streaming client, then it's definitely going to be money. And the reason why it probably is set up on a VM and why it can't be run locally is probably how it needs to, the way that it's set up for that course.
Well, you're using Isaac Sim, right?
Yeah, but there's probably also I'd be interested to know if it has to be on a Linux machine, right? And that's probably why you can't run it locally.
It used to be, but that's how the VMs are all on Linux machines. But
then that's probably why it's not like a local copy, because the way that it probably works is you have to have a Linux machine in order to do some of the stuff that they are introducing into the course.
Nah, I did. I'm trying to remember the course. I think it's just because they're Linux VMs. I mean, I don't think that they really publish tutorials that you just do on your own computer. because people then they have to teach people to do the environment too, or set up the environment instead of Omniverse. But maybe we should, huh? I don't know.
Yeah, you know what? I'm actually checking. I'm going to see if there's any way if we can get credits for the community team that we can give away to people in the community who have a need.
That'd
Oh,
be
you-
great.
I will
You know.
check on that and get back to you. But Birday, thank you for pointing that out.
Yeah, thank you. Yeah.
Because if it has anything to do with Ross is only Linux.
Yeah, that's right. Well, Ross is only Linux. Containers, I found, they technically work on Windows because of Windows subsystem for Linux,
Mm-hmm.
but there are limitations. For example, you can't run, like if you wanted to run a container that runs a graphical application, you can't do that on Windows. There's kind of some limitations like that. So, who doesn't have Linux? I didn't until just a few days ago. I've been staunch Windows person, but these roboticists are all about the Linux.
It's because the OS isn't as heavy as Windows. Windows has very heavy OS.
Well, I get that for the robot, but why for your own computer? I guess
Because who wants a heavy OS? Like I would agree. I usually prefer Linux for like most of my development.
Uh-huh.
I am definitely a Fedora user over Ubuntu, but that's because I do like a lot of math stuff on there usually. But but if I play video games, Linux is not the way to go. You go Windows. I'm sorry, like.
Or I think CAD is. I think for CAD as well. You know,
Yeah,
most
CAD's
business
best on
software, Windows is the way to was
I
why
would
I was in
agree.
the CAD world. That's why I always used .NET. Did .NET development before here, just because of all that, you know. But I think also for Linux. Just a second. Yeah, I think also. I forget what I was going to say. Bird asked if I can open the Technic buggy in IsaacSim. Yeah, no problem. Let's open it.
Run Windows on a Linux server? No.
That would be weird. Would you like to see the stage? Nah. Yeah. Interesting comment from Kai. All these environments are just containers, so as long as you have CUDA container toolkit, it should work, because that is the hardest part to get working. Yeah, containers are a little bit tricky. And I don't know if my arrow keys will work to drive this thing or not. I'm going to run and get a gamepad and be right back.
It's cool to see the physics though when it just dropped into the scene.
Yeah, and then if you notice the springs when it had like that feedback.
Yeah, totally cool. It's a very cool looking RC.
So just so you know, Edmar, and as it's recorded on live stream, I ended up actually also getting a live thing. So it's it'll be there for the next stream. It just arrived today, but I didn't have time to put it up.
Oh. Now
mine's fancy.
Tune in next week. Awesome. Did you get a did you get to Hobby Lobby or did you go someplace else?
No, I got it online.
Okay. All right. We'll see whose is better. That's be the challenge. I'm guessing yours is. For anyone who can't tell what we're talking about, Jen was noticed the on-air little thing on my shelf there yesterday, and she's very competitive, as you can tell. She's got to get one that's better within hours.
I gotta step up my game, man. If I'm gonna be, in some live streams, I gotta be on par with Edmar, the professional over here.
My word of advice to the community is do not mess with Jen.
So you've got to turn off gamepad control for it to work. Oh wait, No, we want that off. Okay. There we go.
Ah.
Oh man, that is
Yeah.
cool. You know, you need to get that working on Frank Shang, aka Shang-Chi, his Mario his Mario racetrack he made. That would be awesome.
That'd be fun.
Your Vermont accent is coming out.
And by the way, just
Darth?
so y'all see,
Well, because you're saying Mario.
Oh, I think my mic, because my mic goes into Darth mode once in a while.
Oh.
I don't know if Vermont has it. I'm a New Yorker, so I'm
Well, you definitely don't have a Brooklyn accent. My grandfather does. So you must be
I'm from
upper.
Long Island. I'm from Long
Yeah.
Island, so
Okay.
Mar-IO. I like it. Mar-IO, because we're roboticists. A couple of questions about the well, yeah, so the controller support, probably what's going on if you're opening it in Composer is by default, if you reopen it, by default, if you go to this navigation setting, if your gamepad camera control is on, it will break the gamepad support. That's the most likely culprit of if your gamepad's not working. And for, as far as this Technics demo, now you can use Composer or Isaac. I actually put together, I mean, it's all USD in the background, right? So I actually put together the RC card in Composer, and then now I open it in Isaac. No problem. Yeah, either way. I think there's some specific steps. If you once we want to actually do reinforced learning, things get a little different because you have to essentially containerize everything so that you can launch as many instances as you want in Isaac Gym. So it gets kind of we'll I don't know how to do that. We'll figure it out when the time comes.
Mm-hmm.
All right. All that said, I just wanted to share that progress with you, and hopefully by next week I'll have it working in real life, and probably the steering and the throttle, and it might even, we'll see how far I can get. So
very cool.
Yeah, we're getting there. Fun stuff. Thanks for joining us, Edmar, and again, Jen. And
Anytime.
I think we're going to wrap things up, and we'll see you all next week. Once again, join us in Discord if you want to hear about this, talk about it before then. So,
yeah, and if you're also interested in next Wednesday's live stream, we're going to have the Convey team on. This is super exciting. I don't know if either of you guys saw this demo.
No.
Showing a player interacting with NPC in real time using AI. So,
really?
Yep, Convey showed this off in I think it was an Unreal scene that the team worked on, where the player kind of walked up to a bartender and started chatting with him in real time. So I believe in that demo
those guys.
It was text, but I got a sneak peek at something to prepare for this live stream. And they're going to show off, if everything goes smoothly, they're going to show off actually full real-time audio communication with an NPC character. In other words, talking into the microphone and having it talk back to you. Super, super cool. Convey actually built an Omniverse extension, and it's currently, I don't think it's compatible with the latest update, so they're working on that now. It's the USD Composer release just came out recently, so that they've got to tweak a couple things, but we'll have them on the live stream next Wednesday. So everyone should check out our event calendar. I'll post a link in the chat right now, so you can make sure to put it on your own calendar. Super easy, and it'll be really great to see you folks there. And I see some familiar faces in the stream, so that's awesome. What's up, Ben? Ben from Alara Systems is here. Who actually did a really cool submission for that start to finish that we were just talking about earlier. So you gotta follow us on social media to watch that.
Cool.
Okay, cool. And just to list this just in a second ago, things are moving along with my request to get a credit for the DLI course. So I've got some wheel spinning here. So we're going to see if we can work something out. So if we can do anything, we'll update you on this stream, hopefully by next week.
That would be epic.
Yeah. If not, if there's a couple of you, just PM me and I'll send you some PayPal. All right.
And thanks, Edmar.
Yeah. Thank you, everybody. Good to see you guys.
Yeah. And I think we'll see y'all next week.
Mhm.
Bye.
Bye, everybody.